Welcome to my YouTube channel S.K.Y Innovatives. Today I am going to learn about linear search algorithm in an array. What is linear search? Linear search is we have given an array and we have traversed whole array linearly and search our element. Okay, how linear search work? Let us see. We have given an array with name array and index I have represented. Its starting index is 0 to 9. Total size of array is 10. We define lower index is equal to 0, upper index is equal to 9. Algorithm for the linear search. Uh, we have given an array at an element which we have to search. Our lower bound and upper bound. Lower bound and upper bound is not necessary. In some problems you have not given lower bound and upper bound. Then if you are writing a program in C, C++ or Java, then you can assume lower bound as a 0 and upper bound as a size of array minus 1. Now we are going to search our element in array. If array element at ith index of array, if the element is present, then we return the index of element. Okay, else if our element is not present, by traversing whole array, if our element is not found, then we return lower bound minus 1. Basically in C, C++ or Java we return minus 1 since lower bound is 0. Now we are going to talk about its time complexity. Uh, generally time complexity of linear search is big O of n. That means it takes maximum n times to search our an element. In worst case, its time complexity is big of n, where when element is present at the last index of an array, then we have to traverse whole array. Okay, then we have to traverse whole n minus 1 n element. That's why its time complexity is n. Or in best case, its time complexity is big of 1. When an element is present at 0th index, then its time complexity is big O of 1. Let us see. Let us assume an example. Let us we are searching for 1. Then we we have an element that is 1. We are searching for 1. Go into this low is equal to 0 for from 0 to upper n minus 1 or size of array minus 1. We are traversing. Then first we traverse 0, no. Again increment the I value at index 1. Is our element present at index 1? No. Then again increase our I value and at index 2. Is our element present at index 2? No. Then again increase our index by 1 and we are at the index 3. And as you can see, our element is found at index 3, so we return index 3. Okay, so now move towards Visual Studio and see how it works. As you can see, I am not taking lower bound and upper bound. I am going to assume it by own. We have given an array with I am doing work in C++, so I am using a vector. Vector is also like an array. Okay, but only difference is vector is dynamic and dynamic size, vector has dynamic size and array has static size. Okay, so let us write a code. Declare two variable low is equal to 0, comma up or high. I am going to use up is equal to array dot size minus 1, size of array minus 1, as I told you earlier. Okay, now we are going to traverse whole array. if our element is present in array or vector, then we return the index of our element. Otherwise we return lower bound minus 1, lower bound minus 1, and we already told you earlier that lower bound is 0 in C, C++ and Java. So we return here minus 1. Okay, save this file and run. As you can see, it is asking for an element in target element. Let us I am in searching for 1. As you can see, it is going to show, it is showing successful search element at index 3. You can see here element is present at 3. Now again I am going to run this and showing unsuccessful search. Let us, we are going to search 56. Is it present in it or not? I do not know. Yes. As you can see, 56 is not present in an array. It is showing unsuccessful search. Okay, you can see code here also in code. Sorry, you can see our array. There is no 56%. One is present at third index. So it return third. Okay, thank you for watching. Like, subscribe, and share with your friends.